Alright, this is the video lesson for 6-1, solving systems of equations by graphing. So first of all, first vocabulary word that we run into here is what a system of equations is. And you can see here that a system of equations is simply more than one equation graphed on a coordinate plane. So more than one equation graphed on a coordinate plane. Could be 2 or 3 or 4 equations graphed on one coordinate plane. Now what we're going to be dealing with today mostly is the two equations graphed on the coordinate plane. Okay, so let me scroll down here. Sorry, I took the definition off of there. You can go back, obviously, to see it if you need to, but I wanted some more room down here to look at our examples. So, the type of system, one thing that can happen here when you are graphing a system of equations is that you could have intersecting lines, meaning this. You have your coordinate plane here, and you have two lines graphed on it, and what happens is these two lines intersect. Well, they intersect at one point here, which means that your number of solutions is 1. You have one solution to this system of equations, and that one solution is that point right there. Let's just pretend that point is 3, -1. 1, 2, 3, -1. So the two lines in this case crossed at the ordered pair 3, -1, so that means that you have one solution. The importance is that the equations are different. The equations are different. Obviously, for two equations to be two different lines, you have to have two different equations. So, two different equations, completely different. They just happen to cross in this one place, and that means they have one solution. Now, another thing we could have here is we could have a system of equations where the two lines you graph happen to be the same line. So, for instance, I graph this line right here, and then I come back and I graph a different line, and it happens to be right on top of this line, same exact line. Well, what that means is you have infinitely many solutions. You have infinitely many solutions. And why do you have infinitely many? Because where do these two lines cross? Well, they cross, right here, right here, right here, right here, right here, right here, right here. They cross everywhere. They're on top of each other, so they are always crossing, or they're always touching. So there are infinitely many solutions. All of those dots I drew there, all of those could be ordered pairs that work for both of these equations. The importance of this is that the equations are the same. Obviously, again, equations are the same. Now, they might not look the same right at the beginning, but we know in order to graph, we have to turn the equation into y equals mx plus b. So what happens here is when you turn these two equations into y equals mx plus b, they come out to be the same exact equation. Same exact equation, obviously then the lines are right on top of each other, same exact line. Alright, and the last option we have here is that we could have two lines, and when we graph these two lines, they end up being parallel lines. Like this line and this line. Okay, you might graph your two lines and they're parallel. Well, how many solutions are parallel lines going to have? Well, parallel lines never cross, so they're going to have no solutions. So no solutions to this equation, and the importance of these equations is that they're the same slope. The two lines are going to have the same slope, or the same m, but they will have different y-intercepts, or your b values. So they're going to have the same slope but different b's. And again, you can figure that out based at looking at the example picture there. So let's then move on to some examples next. And as you look at these examples here, the 1 through 4, the directions say to use the graph at the right to determine whether each system has no solutions, one solution, or infinitely many solutions. So for problem number 1 here, it says y equals negative x minus 3. The nice part about this is they've already graphed it for you. You can see that right here they're saying y equals negative x minus 3. So this is the first line that they're talking about. And then the second line is y equals x minus 1. And y equals x minus 1 looks like right here. Looks like they're talking about this line. So with these two lines, they cross at one spot here. So that means that these two lines have one solution. And if you do have a one solution answer, you need to tell me what that one solution is. So these two lines have one solution, and you can see that that ordered pair right there is the ordered pair -1, -2. So -1 comma -2 is where those two lines cross. Okay? Alright, very good. So then you move on to number 2, 3, and 4. You should be able to figure out how many solutions these equations have based on whether they intersect, don't intersect, or are the same line. So pause the video, try 2, 3, and 4 on your own. Alright, and we're back. Problem number 2 here. The first equation, again I'll do this in blue, is 2x plus 2y equals -6. That would be located right here, so that is this line. If you notice, this line has two different equations for it. So that's that line. And then, like I said, this equation is also y equals -x minus 3, which is right here, so it's pointing at the same exact line. So these two lines are right on top of each other, which means how many solutions do they have? They have infinitely many. Now I'm going to let you abbreviate infinitely as just INF, infinitely many solutions. And number 3, let me erase my lines over here. Find the two lines that they're talking about. The first one being y equals -x minus 3. That's a popular line, this line right here. Again. And then the other line that they are talking about, wrong color. The other line they're talking about is 2x plus 2y equals 4. Looks like that equation is pointing at this line right here. So those two lines look to be parallel, don't they? And if you're not sure, you could check. Looks like this is a point right here and this is a point right here, or yeah, this does have a slope of -1. You could either solve this equation for y or just again look. It looks like there's a point right here and a point right here. So that, yes, also would have a slope of -1. So these two equations have no solution because they never cross. They are parallel lines. Okay, and for our last one here, we'll look and see the first equation says 2x plus y equals -6. I think we just used that one. That's this line again. I think we used this line in every problem so far. And the second line is 3x plus y equals 3. That's a new line, 3x plus y equals 3, so that's this line right here. And again, you can tell that these two lines are going to cross. In this case, it does happen to be on the last one. Now, understand that even if you can't see where they cross, if you know that they will cross, you're still going to say that they have one solution. Now, if you can't see where they cross, you either need to change your graph or the problem's just too big that you can't see it. But in this case, let's see where they cross. They cross at that's +1, 2, 3. So 3, and then down 1, 2, 3, 4, 5, 6. So they're going to cross at the ordered pair 3, negative 6. So there you have it. Those were some problems where they already graphed the line for you, and then you told me, how many solutions are there and what the solution is if it was a one solution answer. All right, now on the next set of problems, 5 through 7, you'll be doing that all on your own. You will have to graph the equations, and again, as we said before, in order to graph equations, you have to have them set up in the y equals mx plus b format. So all these equations have to be solved for y. You then graph them, again, as a review here, using your b as your y-intercept, which is also your starting point. That's where the graph starts at. And then using your m as your slope, and again, slope is rise over run, and you'll use this to graph these equations, and then after you graph them, you tell me how many solutions they had and what the solution was if it was a one solution answer. So let's look up here. First problem, number 5, looks like this equation is already solved for y. I'm going to do it in blue. It says y equals 1/2 x plus 0. So we're going to graph it. It starts at 0, and then its slope is up 1, right 2. Up 1, right 2, or down 1, left 2 would be the exact same. Down 1, left 2. So it looks like this is our line for the first equation, which I've done in blue. I'll do the second equation in red, but the second equation is not solved for y yet, so I have to start this equation out by subtracting x on both sides, which gives me y equals negative x plus 3. Alright, and that one now is solved for y, so we can graph it. We'll start at positive 3, 1, 2, 3, which is right there on the y-axis. Our slope is negative 1 over 1, so we're going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, or the exact opposite, up 1, left 1, up 1, left 1. Now, one thing you're going to want to do on graphs in this section, one thing I'm going to make you do on graphs is you need to continue to write points. Plot those points, those down 1, right 1s, down 1, right 1s, until you can see the two lines run into each other. Because if your lines aren't straight, you might get the ordered pair wrong. So continue to use that slope to plot all the points that you need to plot in order for the two lines to run into each other. So you can see in this problem I have circled where they cross. So the answer to this problem is that it's a one solution answer. We have one solution, and that one solution is the ordered pair 2, 1. So one solution, and the solution is the ordered pair 2, 1. Very good. So again, I'm going to go ahead and do the second one with you guys, and then you can try the last one on your own. The second one I want to do with you because there's some solving to do here. Again, each equation, neither equation is solved for y. So in the top equation, which again I'll do the top one in blue, I'm going to subtract 3x on both sides. Subtract 3x, I'm going to move this equation up. So I now have 2y equals negative 3x plus 6. And then last step for this would be to divide both sides by 2, making my first blue equation here y equals negative 3 over 2x plus 3. And I like to go ahead and graph this as soon as I get it. So let's go down to the graph, and we're going to start this equation at positive 3. We're going to move down 3, right 2, down 1, 2, 3, right 2, down 3, right 2 again. Looks like those are the only points I'm going to fit on here. And there's my blue line. My red line, or my second equation, again, first step is to subtract 3x on both sides. That'll give me 2y equals negative 3x minus 4. Again, in this case, I'll divide both sides by 2, making my red equation y equals negative 3/2 x minus 2. Now, first thing you should notice about this is that these two lines have the same exact slope. I already know they're going to be parallel. I already know my answer is going to be no solution because they're not going to cross. And the reason being is because the lines are parallel, but they start in different places. This second line, the red line, starts at negative 2, and it goes down 3, right 2. Down 3, right 2 is actually off the graph when I go down, so I'll do the opposite. Up 3, left 2. Up 3, left 2 again. And you can see that this line looks like this. And yes, they are parallel lines because they have the same slope. If they have the same slope, there is no solution. That's all you have to write. Very good. So try the next equation on your own. And we're back. The next equation, or the next problem, equation number 1, again the one I'll do in blue, I'm going to start out by dividing both sides by 2. There we go. Divide both sides by 2. So this equation should say y equals negative 4 over 2, which we know negative 4 over 2 is just negative 2. So y equals negative 2x plus 2 is my first blue equation. So we go down to, or we go up to positive 2, and then our slope is negative 2 over 1, so we go down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1, and we have this line right here. Now, right away you should have noticed when you look at your second equation, the one I normally do here in red, it is already in slope-intercept form, and it is the exact same equation. Y equals negative 2x plus 2, which means this line will be graphed in the exact same spot right on top of that line, which means in this problem we have infinitely many solutions because the two lines are always crossing. Now, you don't actually have to draw the line on top of the line. I do just to show you what's happening there, but you can just have the one line graphed, obviously. All right, very good. So, once again, moving on to our last problem. Our last problem is a story problem, which we need to work out and understand. Story problems are very important here. Oops, sorry. So, problem number 8. There's actually a couple things I want you to change so that this problem works out a little bit better. It says, and just read this along with me because you'll make the changes as we go along. It says the Rodriguez family and the Wong family, sorry about that, passing period bell. The Rodriguez family and the Wong family went to a brunch buffet. The restaurant charges one price for adults and another price for children. The Rodriguez family has 2 adults and 3 children, and their bill was, and we're going to change that from $40.50 to just $45. $45 even. This will make our graph come out a little bit prettier. And then it says the Wong family has, and we're going to change from 3 adults to 1 adult, and we're going to change from 1 child to 2 children. And their bill was, and we're going to change from $38 to $26. Alright, so a couple changes there. So the Rodriguez family has 2 adults and 3 children, and their total bill was $45. The Wong family has 1 adult and 2 children, and their bill was $26. It says determine the price of the buffet for an adult and the price for a child. Now again, this is one of those problems where we're going to have to come up with what are you going to let your x variable represent, what are you going to let your y variable represent. Okay? I'm going to let my x variable represent the number of adult tickets. Now, by tickets, I actually mean, you know, the meal that they had to pay, the bill ticket for that one individual adult. And then the y is going to represent the number of child tickets. or you could just say it represents the price of an adult meal and the price of a child meal. Actually, I think I like that better. Yeah, let's actually change that. I do like that better. Let's say this is the price of an adult meal and price of a child meal. Because that's what we don't know. We don't know what they're charging each person. So we need to write two equations here, obviously, because we're doing a system of equations. And the first equation is going to be 2 times x, because the Rodriguez family has 2 adults, plus 3 times y, because they have 3 children, and that equals $45. So 2 times the cost of an adult meal plus 3 times the cost of a child's meal. You add those together and their total bill was $45. Now the Wong family, we had them with 1 adult, so 1x, plus 2 children, so 2y, equals, and their total bill was $26. So right here, you've already got a bunch of things that you needed to do. You needed to, over here on the left, identify what your x and y values are. That's, labeling your variables. And then you needed to come up with these 2 equations, which is what's happening in the problem. Now, in order to find our answer here, we want to know how much the adult price was and how much the child price was. So down here in our graph, I'm going to say that the x-axis, the bottom x-axis, is going to represent my x's, which were adult price, and my y-axis is going to be the child's price, and I'm going to label these for the adult price. I think I'll be good by just counting by ones. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I doubt the meal will cost more than $14. Same thing here on the child's price. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, before I graph these, obviously I need to solve them. We'll do the first one. I should have done the 2 equations in different colors. We'll do the first equation here in red. I need to start that out by subtracting the 2x. So I'm going to have 2x plus 3y equals 45. We're going to subtract the 2x on both sides. So 3y equals negative 2x plus 45. And then we'll divide everything by 3. So our red equation is y equals negative 2/3 x plus 45 divided by 3 would be 15. So let's graph that equation. The y-intercept is 15, which is actually 1 dot above room on my graph, so I'll go just right there above the 14 at the 15. It would be 15, and I'm going down 2, right 3. So down 1, 2, right 3, down 2, right 3, down 2, right 3, 1, 2, 3. Oh, I messed one up there. Let's go down 2, right 1, 2, 3, down 2, right 3, down 2, right 3, down 2, right 3. Kind of ran off the graph there too. Hopefully that's going to be okay. Oh, let's try that again. Get that a little straighter. There we go. Alright, so there's what this one looks like. Hopefully this graph is big enough. Might not be. Might be that I need to go back and count by 2s, but we'll see. Now, we'll do the second equation here. in blue, and we're going to have 1x plus 2y equals 26. So we'll start this out by subtracting x. So 2y equals negative 1x plus 26. Divide both sides by 2, so y equals negative 1/2 x plus 13. And again, I don't know why I wrote that in red. That is going to be my blue equation, so we'll box it in blue here. So this equation starts at 13, and what's its slope? Down 1, right 2. So down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. That's close to the line, not on it yet though. Down 1, right 2, down 1, right 2. Now, this is a little confusing because my line's not exactly straight, and that's again kind of the tough part here. It'd be nice if I could use a ruler on this, but let's look at my red line. Again, I'm actually going to erase a little bit of this red line and try to get it more right on where it actually is, because there was a dot there. Oh, what happened? Oh no. Great. And we're having some technical difficulties. What just happened? Alright, we will back out of here and hopefully it will come back. Whew, thank goodness. I was hoping not to have to redo this whole video. So, again, I'm going to try to make this red line a little bit more accurately on the points, because as I'm graphing these blue dots here, they're getting really close to the line. Down 1, right 2, down 1, right 2. Those didn't actually cross yet. Now I go down 1, right 2 again. Still didn't cross yet. Down 1, right 2 again. Right there is where the two lines are going to cross, because those were actually where a red point and where a blue point both were. And again, this is you got to be accurate on this stuff. And then that's actually where the blue line crosses over. So as I connect these, they're running real close together until they finally cross over. So this should give us our final answer here. What is this ordered pair? Well, this is looks like it's a 12 on the adult side and a 7 on the child side. So, you know, this ordered pair is 12, 7, where the two lines crossed. And again, that's why you label your variables. 12 is the x, so 12 is the adult price, and 7 is the child price. So $12 for adults and $7 for child. I've run out of room here, but you would need to write that in as a full sentence answer. But there you go. That's how you do one of those story problems. This was kind of a long video. Hopefully you paused and watched things closely so you can do the homework now. Thank you.